Yeah, like Marcus said, we're zooming out, so now a bit more on the strategic level. So this preECO is a DFG project running for 3 years. I already told you about this last year, so it's a bit a tricky situation that some of you have heard the talk last year and others didn't. So I also included a bit of a recap, but I mainly want to talk about what has happened since last year. Yeah, and our big goal is here to improve the quality of adapters and application cases. Like you have seen, they pop up everywhere, and we're very happy about this. But we're also losing a bit control right now. And to get control again, or to make things maintainable, we need to bring a little bit more of standardization, a little bit of order to the new tools. Okay, so on a very high level, so this is the project preECO. The long title is a community-driven ecosystem of adapters and application cases for the coupling library preCICE, and started last year, and it's running till 27, presumably. And the objectives of the projects are: we want to improve the fairness of adapters and application cases. We want to enable the community for adapter development. Yeah, so that's you, right? You already can develop adapters, but we want to enable you even more. And we want to make application cases reproducible. And how do we want to do this? 3 measures. Number 1, we want to design and implement standardization and quality control of adapter and application case development together with the community. Yeah, so this is not something we can simply force you to do, but this is something we need to develop together. And this is the main part of this talk. And then other things, simplify adapter and application case development via automation. So for example, tools to generate and check preCICE configuration files. So this you will hear tomorrow by Felix. And disseminate good practices via community training. Many of you took part in our training this workshop, so we will further build on this. And eventually we want to integrate these guidelines also in the training. So most of this will happen next year in the training. Okay, if you want to learn more, the talk from last year is also on YouTube. So under the preCICE channel on YouTube, you will find the talk. So a little bit of recap. So what is the big problem with adapters? Yeah, so they're popping up, kind of an uncontrolled growth, and it's becoming harder and harder to maintain. Some of the adapters have an unclear state. We have very different software designs, and which is also okay, but giving a bit of names to these designs would also make our life easier. We have very different quality levels of adapters. This makes also the life for you sometimes harder. So yesterday there was a question, which FEM adapter solver should I use? And there is no good overview of which adapter supports which feature, and that you could just choose which one you want to use. They all have different configurations, and it's not clear what preCICE features they support. Similar thing on the side of application cases. So maybe first, what is an application case? So, for example, here on the right, you see an application case. So this is a data set that is uploaded to some data repository with a DOI that was made to reproduce results of a paper. So this is already very nice. This does not happen for every paper that is using preCICE. But still, there are some issues there. So maybe to explain, so what is an application case? This could be a case to study application-based research questions. I think most of you do this. It could also be a case to study coupling methods. It could be a test for regression. It could be a case to learn preCICE. So all of these cases we call application cases. And what problems do we have there? So often, if we see a paper that is using preCICE, it would already be very nice for us if we only could see the preCICE config that was used. This would already answer many questions that we have while reading the paper. So often this is not the case right now. At the same time, we have the problem that we are lacking real cases to test our coupling methods. Okay, so we have like a new fancy data mapping method, but how can we test this in a real setup? Okay, so if we had your cases that could just run out of box and we know what we can observe, then okay, we would cite your case and we could use it to test our methods. Yeah, but even if cases are published, they're not easy to run. Sometimes only the version of preCise is given that was used, but not the version of the adapters or the modifications that were necessary to the adapters. Yeah, and at all, we don't have an overview of all the cases that are out there. Okay, so what do we want to do? We want to standardize a few things. So what is standardization? So very brief. Standardization is that we define that the preCise config needs to be called preCise config, that you should not call it config or preCise.xml. Okay, it's not that the one is better or more correct than the other one. It's that, it has some value in itself if we all use the same thing. Then you have to, and then you can stop thinking about it and you know directly where you have to look. And you can develop tools on top and many things. Okay, so what we did is we developed guidelines, so 2 lists, one for adapters, one for application cases, that you can find on the website. I'm going to show you in a minute. So these are 2 screenshots. And there we define rules or recommendation, best practices, however you want to call it, on how we envision what is a preCise conforming way of developing an adapter. What kind of features does an adapter need to have to be like a fair adapter? So a bit the timeline. So last year at the workshop, we presented the first drafts of these 2 lists. And then we discussed them in the World Cafe. This was very helpful for us. We got a lot of feedback there. Since then, we did a few updates. We wrote about this in the forum. And we did further releases of the guidelines. And now at this year's workshop, kind of the idea is to prepare a bit the first major release. So the major release is really meant to, this is kind of more or less a frozen state that we all agree and that we now want to start working with. And we're also going to present you the tools that we're going to develop. Yeah. And then the further idea is we want to implement a review procedure then in the next year, and eventually in 26 then do training on standards and tools. Okay, so this was a bit the recap part. Now what really happened last year. So we did a few updates on the guidelines, and we also wrote about this. So this is a blog post on the forum, where we a bit discuss what was the feedback that you gave us last year and how we reacted to this. So there were many things, but the main things were, in principle, everyone sees the added value for visibility, generality, maintainability, and reproducibility. But there was some criticism on this bronze, silver, gold tiering system that we suggested last year. Main criticism was a bit in the direction that this could be misused as a scientific metric, which it was not intended to, but we see that this could be misunderstood this way. So we got, jumping a bit to the conclusion, so we got rid of this. We now have 2 levels. We have one level that we call required. This is the real thing, so the interoperability. And then there are more additional other best practices that you can add. But in a way, it's only one level that you should achieve to say that you're preCise conforming in your adapter development. And the other feedback that we got is how can we really get feedback from you? How can we test the guidelines? And their suggestion was, we have to try it with you, with some of you. And this is also what we did. So we worked with a few of you as early adopters and just tested the guidelines on a few adapters, whether the adapters fulfill the criteria or not. Okay, that's a bit the introduction. Now let's really look at the guidelines. So there are 4 links here that I now want to show you on the website. Yeah, let's jump to the website. So this is the guideline for adapters. Is this readable in the back? Yeah, thanks. Yeah, so you find this under community and then under contribute adapter guidelines. This has a bit of a preamble. This is basically what I now explained you in the presentation, so we can skip the preamble. And now what is in these guidelines for the adapters? So you have to specify some metadata. Yeah, these are very clear things. So for example, the name of the target solver that you want to couple, and for example, also what kind of type of adapter this is. Is this like a standalone thing, or is this an integrated thing? Is it just a patch to a code? Is it a collection of examples? Yeah. And then the best practices, and there's the category required. And yeah, I'm not going to go through everything, but just to give you an idea of what kind of things are in there. So for example, the first thing here says that the adapter needs to be accompanied with at least one application case to test it. Okay, if this is not the case, we do not know how to test the adapter. And then we need certain documentation, so there needs to be a README. And in the README, for example, you need to explain how to build and how to configure the adapter and how to run the test case that you provide. And in the documentation, you need to specify which precise features are supported by this adapter. So we will have like a curated list, and you simply have to tick which features the adapter supports. Yeah. Then we have more like general best practices that are not really specific to precise. So you need to have a clear license, you need to have a version control system, a versioning scheme, a changelog, an issue tracker, a code formatting, and comments in the code, right? So this is nothing specific to precise. This is something that every good software should have. Now comes an important part. The configuration of the adapter needs to follow a certain schema, so a certain standard. So in the first place, you need to have a configuration, and then the configuration needs to be follow the schema. So this I will explain you in a few moments, and I skip for the moment. And then we have additional ones. Just to give you examples, what are in the additional ones? So for example, that you have contribution guidelines, or that you have documentation on how to extend the adapter. Okay, so this goes more in the direction on others should also help you, be able to help you maintain and develop the adapter. Okay, so now we had this list, and we have a fixed release of this list now, and now we looked at a few examples. Do they fulfill the list or not? So one is the open foam adapter, and just to see how this could look like, so we now have kind of a response to this list where we specify the metadata, and now for each criterion we kind of give the answer, and this can be very short. This can be just like a link to where the license is or where the versioning scheme is explained. So this is not a lot of information that you have to give. Right now this is still kind of a placeholder. What we have in mind till hopefully next year is that we have like a nice rendering of this information on the website, so that you don't have this list, but we have like a machine readable way of this information, and then we can do a nice rendering on the website, and we can make this searchable, and things like this. And what you also see is that yeah, also for the OpenFOAM adapter, not all the boxes are ticked. So right now, we don't require at all that you tick all the boxes. Right now, it's more that we learn what boxes can you actually tick, and that we learn where we need to either modify the guidelines or help you to fulfill the guidelines. There are more examples. So this was OpenFOAM, but then kind of in a nice push before the workshop, we got a few more. So there's now also like an example for OpenDHO and for ISSM. And others are work in progress. So jumping here, so this is a pull request in the preECO Augur repository, where now the Gizmo developers added such a response to the guidelines. So this is only like one single file that you need to add here, and then in the review we look at it, and we discuss, and give you like. The idea is that we help you to fulfill more or to find out what you fulfill already. So this is also a bit a call to action. So if you also want to add your adapter here, so in the long run, this will be our list of adapters on the website. Please approach us so that we can also, together with you, fill out these guidelines for your codes. So that was the adapter, and now there's something very similar for the application case guidelines. I'm not touching everything here, but maybe give you an idea again. One example, the application case needs to be structured in a very specific way, and this is this structure here. So this is exactly what we also use in the training course. There you see everything is always structured the same way, and also how we structure our tutorials. So specifically, you need to have subfolders for your different solvers that you want to couple, and the precise config needs to be on the root level of the application case. This means that if you have such a communication in your precise config, the exchange directory always needs to be ... pointing one level up, and that the cases can be run from the subfolders. Okay. Again, this is not that this is like the best way how to do it. We just have to define one way how to do it. Then if everybody follows this way, then if you get a new application case from somebody else, it will be very quick that you understand what the case is about. You know exactly how to start it, and you can build tooling on top of it. And use the tooling with different application cases. Okay, let's maybe not explain more details here. Quickly looking at the time. Yes, so these were the guidelines. I also want to show you a bit the schema. So this is the configuration schema. So also for this, we wrote a blog post early this year. I'm going to explain most of the things of the blog post now also. And then I'm going to use this tool, Meta Configurator, that Felix is developing. If you want to learn more about Meta Configurator, I also recommend discussing with Felix at his poster. So Meta Configurator is on GitHub as well, so under its own organization. And it is hosted constantly, so there are two different variants. There's a developed variant and there is like a stable variant. If you click on this link here, so metaconfigurator.org, you get to the stable variant. So this is the tool, and in the beginning it will ask you what kind of schema do you want to use, and you can say example schema, and the precise adapter config is one of the example schemas. So we're going to use the example schema, and now you see already I get like a snippet of a config already, because the tool now already fills all the things that are required components of the config. It already automatically fills with some example data. So you see that you're going to have a participant name. Maybe make it a bit larger. Participant name, that you have the path to the precise config file, and that you have one interface with a mesh name. So what does a schema now do? A schema defines how exactly this should look like. So for example, that it's precise config file path and that it's not precise config. Yeah. If you do this, then also the tool here will complain that it does not know this one here. Yeah. But it needs to be actually precise config file path. Okay, so it's really about the semantics of the config. It's not so much about the language. So this one happens to be here in JSON, but you can also switch, for example, here from JSON to YAML, and then you have the same config in YAML. Yeah, so it's more about really using the right names and that the names have the correct meaning. So switching back to JSON. So what can you now do with this? So the schema defines how this should look like, but for example, with the schema, we can now also construct a GUI. So this tool also comes with a GUI. So for example, here now in the GUI, you could switch from fluid to solid, and it gives you some examples here. Okay, solid, but you could also fill something else. You could say this is solid 2. Yeah, or let's switch back to fluid. And you see that, yeah, on the left, it's always updated. And now in the GUI, let's say on this interface, now let's, on the mesh that we have here, now let's add a write data. Yeah, and now you see on the left, it added a force. This is also just one default name. You could use something else here. Could say this is also displacement. And it also gives you documentation. So for example, if you hover over here, you will see that some documentation is coming on what is behind this field. Okay, so this is also very nice because this means if you develop an adapter, you don't have to write any documentation on your configuration. Right? Just say, I'm sticking to the standard, then you get the complete documentation already. Yeah, and what do we now concretely have here? So such a write data field can have a name. So this is the name that precise uses, but it could also have a solver name. If ever you need to use a different name on the side of the solver, so for some adapters this is the case. If you ever want to apply an additional operation, like the thing you get from your solver, and then you want to compute the gradient of it, so there's now a standardized way how to define this. Or if for like a flux, you want to flip the direction of the flux. Okay, so this was the data view. So you can switch here from data to schema, and now you can inspect how the schema actually looks like. And the schema is written in JSON schema, and if you're not a JSON schema expert, it's a bit hard to read. But the tool here gives you a lot of nice ways how to still modify the schema and how to read it, how to change things. So for example, here it gives you like a graph-like representation of the schema. Further nice thing, if you have a schema, you can auto-generate code. So here in the tool, you can, where is it? Yeah, you can generate source code. And then you can say in which programming language. So for example, say you want Python code. Then this will generate here first some Python code on how to validate your config file against the schema. And then also code here below if you want to have the complete structure of your data in the schema. If this is here. Okay, so this is a nice feature. Looking at the time again. Okay, yeah. What else can you do? Once you have a schema, large language models know how to work with your data. So this is also very helpful. So what we also introduced recently is here like an AI view. Let me close some of the other views, the GUI. Where, in the background, we currently use ChatGPT, but in the future, we also want to use different large language models. And right now, you need a key to ChatGPT that you need to enter here. Okay. This in the future, we also want to host like open source models ourselves to have some fallback here. Here you can say how you want to modify your data. So this is work in progress. It does not yet work perfectly, but this is something we're working on. So say I want a second mesh now. You could say add a second interface named fluid mesh, I don't know, left, with 2 read data fields named velocity and I don't know, force. Okay, now you could say modify data. And yeah, it will modify your data here on the left. Still a bit buggy, so it duplicated some things, but it's, yeah, if you know what to do, it's also like easy to fix. Yeah, it's work in progress. This one here. Okay, so the hope is that this will work smoothly in the end, and that you, if you have larger files, you can also modify like this. And another AI feature is now that we can export it. So for example, now you want the same thing in an OpenFOAM dictionary. We are working, like an export to OpenFOAM, for example. And then you get like an OpenFOAM dictionary here, which is also still has a few bugs in here, but yeah, also work in progress. Okay, and this does not only work for OpenFOAM, so it could also be if a code has some very specific format that you don't want to change, we could also work around like this. Yeah. Okay. So to wrap up, what we need now again is to get your feedback. So there are different ways. Give us feedback tomorrow at the World Cafe. There will be one topic on the standardization. You can open issues if you directly want to change the guidelines, or suggest changes, or if you want to point out problems. If you want to discuss more, you can do in the forum. And please submit your adapters and application cases for review, and let's improve the quality together. What are our next steps? So eventually we want to release the version 1.0 of the guidelines and the schema, and we want to formalize the review procedure and the website integration. Yeah, and then we want to create some training on the standards and the tools. Okay, thank you.
Thanks a lot. Thanks, Benjamin. Any questions at the moment for him, Dimitro?
I'm not sure it works actually, because I never hear anybody's.
No, this is for the recording.
Oh, it works. Okay. I have a question about this meta configurator and the generated code. Like, isn't it like more useful when it's like a part of preECO itself? So preECO uses the schema to validate the config and tell me if it's good. I didn't understand the point of generated code in Python with validation against the schema.
Yeah. So it's the configuration of the adapters, right? Not of preECO.
Okay.
So this is on the user side. So you as a user, if you develop an adapter, you need to write a configuration for your adapter. And now that we define how a configuration for an adapter should look like exactly, you don't have to write the configuration yourself, but you could use the generated code in your adapter.
Okay, thanks.
Yeah.
Just as a small side comment, if you are at a university, maybe you could use instead of ChatGPT also the Chat AI from Göttingen.
Yeah, so this is on our to-do list to add more tools, more models here. Yeah. Felix doesn't know it yet. Please talk to each other.
So there's also University of Jülich, which provide their own self-hosted large language models, which we already have integrated. And actually, in the tool, you can define any endpoint that satisfies the API, also from other providers, and it will also work.
Perfect. Any more questions, comments? In any case, Benjamin will be around. You can talk to him. So thanks a lot, Benjamin, once more.